Hello students, welcome to Unacademy. How are you? So I hope your preparation is going absolutely fine. Sorry for a little bit delay. Actually I started the session but key was not working. So that's why it is a 5 minute approximately late is going to start. So as the session is late, so I would like to request you that whatever group you are belonging from, just go and write that class is live, right? And like the session also, just like the session and write that class is live. This is the only thing you have to do. So many students are new here, so for new students I would like to introduce myself. I am Shivam Dixit. I did my MTech from NIT Calicut in thermal science. After that I got chance to work with Indian Oil Corporation Limited R&D as automotive research officer, and after that I'm teaching from last approximately 10 years. From last 10 years I am guiding the GATE and ESE aspirants, and up to now I have guided more than 50,000 students, and many of my students secured single digit and double digit rank. You can go and check in the YouTube, you will get many testimonial videos. Okay, so this is all about me, but today we are here to learn the subject fluid mechanics, and that too also one of the very important part we are going to discuss, that is fluid kinematics. So in previous video we already seen that what is this fluid kinematics basically, right? What is the fluid kinematics, that we already seen in previous video, right? And now we are going to talk about few more thing about fluid kinematics basically. So in previous class we seen that what is fluid kinematics and how to study it, means what is Lagrangian approach and Eulerian approach, all those things we discussed. And after that we discuss one more thing, that the type of flow, right? The type of flow, and that is very important. That is very important. And after that, after type of flow, few lines are there that we need to understand that, because I already told you in case of kinematics, fluid kinematics, the method of analysis is based on some of the visualization techniques. Visualization technique means we have to perform some of the experiment, but don't think that it is going to be completely dependent upon the experiment only. No, these experiment or these lines are going to help you to analyze the fluid flow analytical method also. You are getting my point or not? So these lines are very important, and some of the lines are found practically, some of the lines are imaginary lines only. So these lines are not only help us to understand the flow behavior, fluid behavior, or finding out the fluid properties directly by experiment. Another way is that with the help of the we are finding out through property, that is one thing, right? Like through some doing experiment or something, right? But these are equation, these lines are going to help us to analyze the fluid flow in practically also as well as analytically also, right? So suppose you are doing some set of experiments, and on the basis of that experiment you can predict the fluid flow behavior in other cases. Clear? So this we are going to discuss here. Okay, so very good evening to all of you. So I'll request you all that please go and write in your group that class is live. Okay, then we'll continue. Clear, beta? Okay, so let's start. Okay, before starting the session, beta, I would like to share one very important information. I would just like to share some very important information, that Unacademy is giving you 7 days free subscription for plus, right? You are going to be a plus student without paying any fees for 7 days. Sir, how it is going to help us? Like, see, there are many students who always ask me, sir, I am preparing for GATE 2023 and some of the portion is left, right? Some of the portions, sir, this part is not completed, this part is not completed, sir, compressible fluid flow is remaining, or maybe some people have one subject is not completed. Yeah, let's say your heat transfer is there, or basic thermodynamics or fluid mechanics, or any one of the subject that is not completed. Now you want to complete in thoroughly in-depth manner. So for that you have to take subscription. But here what I'm suggesting you, rather than taking subscription, okay, if you have money, then you obviously you have to purchase it, right? But suppose if you have some money problem, then what you can do is you can use this particular opportunity given by the Unacademy. Now here 7 days subscription is free, right? 7 days subscription is free. Suppose one average student is there and every day he is used to watch the 6 to 7 hour lecture. If you are doing hard work for 7 days, these 7 days, if you are doing hard work for these 7 days, then what will happen? Then obviously you can basically give at least 6 to 7 hour every day. Now 6 to 7 hour, let's say 7 I'm considering. So in 7 days you can approximately cover 50 hours. So in 50 hours you can complete most of the important topic, like most of the important topic, or even if you want for one particular subject I'm talking about, even you can complete one complete subject also if your subject is small. For example, basic thermodynamics, 50 hours is more than enough. Suppose heat transfer is there, heat transfer is not going, 50 hours is more than enough. Engineering mechanics is there, 50 hours is more than enough. You are getting my point or not? So machine design is there, 50 hours more than, vibration is there, 50 hours is more than enough. So this 7 days opportunity you are getting to explore yourself. Now in this you will get all the recordings of last 3-4 years, whatever faculty teaches in Unacademy platform, everything will be visible to you, and you can use this for for improving your concepts, or for 1 or 2 concepts you can develop perfectly. Suppose compressible fluid flow is there, you are not completed yet, you can come to the Unacademy platform, 7 days you just complete it, fine, done. Clear hai beta? Okay, so for this what you have to do, first step is you have to scan this code, or directly you go and download the Unacademy app. Then register and choose your goal, right? Choose your goal as a GATE mechanical, right? Then to activate this, you require one code. So that code you have to use this one, SHIVAM Shivam 101. What do you have to use? You have to use Shivam 101. Just use the code Shivam 101 and start learning. 7 days is yours. Clear hai? So this is completely free of cost, and I would suggest you to use this opportunity. Clear hai? Okay, Mukul, how is the Josh? Ara, Josh is perfect. Maulik Dabi. Okay. Now please listen here carefully. So we were discussing about the type of flow. Basically, for analysis point of view, 2 classifications are very important. One is steady flow or unsteady flow, that is one classification. Another is uniform and non-uniform flow. So first let me explain these things in detail, and then we will move, right? So just a minute, please listen here carefully. For example, you want to check whether a fluid is, right, steady or unsteady. In that case, what you need to do is, steady means something is called steady if it is not changing with respect to time. Then we'll say it is a steady. Suppose a fluid flow is there. In that, if properties of the fluids are not changing with respect to time, then we'll say that it is a steady flow. But you have to make the location as the same. See, to describe the fluid flow, right? If you want to describe the fluid flow, then obviously what is required? You required a few of the properties, like pressure is there, density is there, viscosity is there, velocity is there, so the acceleration is there. So these are the parameters which can describe the fluid flow. Now these parameters are mainly depend upon the 2 things. One is time, another one is space. Now whenever we are going to classify the study and unstudy flow, in that case space will be fixed. Space will be say only time is going to be changed. Only time is going to be changed. For example, we have one system like this, right? We have one system like this. Right, we have something like this. Okay, so this is a basically pipe, right? This is basically pipe, and in this one some fluid is flowing basically, right? Some fluid is flowing. Now please listen here carefully. I want to check that whether this fluid is steady or unsteady. Then what I need to do is I have to choose one section here. I have to fix the location. Now location is fixed, right? Now at this location you have to measure the properties in different time. Suppose at 10 o'clock I am measuring one property, like 10 a.m. for example. 10 a.m. I am measuring velocity. Now velocity value is coming 5 meter per second. 5 meter per second. Now you just change the time, but location should not be changed. So what I am going to do is, now again I am going to measure at 10:30. Again I am going to measure 10:30 a.m. and velocity I am finding that 5 meter per second only. Now this is called as steady flow. This is called as what? Steady flow. Any confusion? No confusion, sir. It is no confusion at all. Means the proper steady flow, a flow is said to be steady flow when the properties do not change with respect to time at a given location. This point you are not going to forget. Okay, now the next one is uniform and non-uniform flow. Whenever you want to check whether the flow is uniform or non-uniform, then it is with respect to the space coordinates. So if you are changing the location, but properties are not changing, then we will say that it is a steady flow basically. Okay, now please listen here carefully. Sorry, then it is called a uniform flow. Okay, now so in this case time is a fix. See, I told you only two variables are there. Space variable is there, time variable is there. So whenever we are checking that whether it is a uniform or non-uniform, then space will be variable but time is going to be fixed. So at same time two locations you have to choose, right? 2 or 3 or many you can choose as per the requirement. So here I can say, let's say at 10 a.m. right, 10 a.m. at this location, and again here 10 a.m. at this location. Same time you have to measure the property in different locations. So let's say here you are getting 5 meter per second, here also you are getting 5 meter per second. Now this is called as what? Uniform flow. Uniform flow. Clear hai? Any confusion? No confusion at all. No confusion at all. Now here one more thing I can say that. Suppose we have here one thing I'm doing that 10 o'clock I already measured this one, right? 10 o'clock I measured, so velocity is coming same. Now 10:30 again I'm going to measure. 10:30 a.m. I'm going to measure here. 10:30 a.m. So what I can say that 10:30, so here velocity is 6 meter per second, and here velocity is 6 meter per second. Now this flow is uniform flow. Why? Because with respect to space value is not changing, with respect to time it is changing. So you can see that at this particular location 1, this is location 2. So at location 1, 10 a.m. value is coming 5 meter per second. 10 a.m. value is coming 5 meter per second, and 10 a.m. value is coming 5 meter per second, and again 10:30 value is coming 6 meter per second. You are getting my point now. So this is basically what I can say. It is a uniform flow but not steady. Uniform but not steady. Clear hai? Any confusion? Any confusion beta? No confusion at all. I hope there is no confusion basically. Okay, now listen here carefully again. Now in this particular case, if you are changing the location, let's say it is a steady case now I am changing the location, for example, right? This is a location 1, This is location 2. Now at location 2, right, location 2, 10 a.m. I am measuring, right, 10 a.m. only I am measuring. So 10 a.m. I am measuring here. So velocity value is coming 6 meter per second. And 10:30 I am measuring here at second location, then V value is coming again 6 meter per second. Now you can see that with respect to time values are not changing. With respect to time values are not changing, but with respect to space it is changing. So this flow is basically steady flow, but not uniform, but non-uniform. You are getting my point? Clear hai? Any confusion, you just let me know. Any confusion, just let me know. Any confusion, you just let me know. Clear hai? Okay, shall I move? Okay, now, so these things we already discussed here, right? So if it is a steady flow, beta, if it is a steady flow, then this is, let's say, rho. So the d by dt of any parameter, it may be d rho by dt or dv by dt or dp by dt, everything is going to come 0 basically. Everything value is going to come 0. Okay, now listen here carefully again. So these are the positions in a tube. Let's say there are a number of positions. Let's say this is a tube beta, right? This is a tube, and here we have a number of location like A location, then here we have B location, then here we have C location, right? A, B and C location. Now t is equal to 0. At t is equal to 0 means at initial position and initial time at location A, right? The velocity here I want to draw steady and non-uniform. Steady means with respect to time value will not change. Means here let's say the velocity direction is this one. Magnitude also not changing. Now with respect same location, after some time I am measuring, then also same. After some time I am same. Means you can see that at one particular location in different time the value is not changing, but when I am changing the location, now B position, then again the value is changing. It means it is not uniform, but at this location every time it is going to be same. Similarly here also. Clear hai this point? Okay, now similarly I can say for unsteady and uniform. So uniform is here, let's say value is what, at t is equal to 0. At initial condition velocity is at this direction. If you change the location, then also it is same. It means it is a uniform. It is basically what? Uniform. But if you change the time, then it will change. You are getting my point? So this is basically the difference. I hope you understand this. I hope you already understand this. Clear hai? Shall I move further? Shall I move forward? Okay. Now next one is coming like rotational and irrotational flow. So when fluid is going to flow, then if the particle of the fluid are going to rotate about their own axis, if the particle is going to rotate their own axis, then it's called a rotational flow. This is, you can see, this is a rotational flow basically. This is what rotational flow, and this is irrotational flow. Now there may be see, you need to know linear flow, circular flow may be different, but rotational and circular is different. See, I'll tell you, then you'll understand basically. See, for example I'm telling you, this is what, let's say the fluid particle are I have one for particular fluid particle, and this is moving like this in this direction, right? It is moving in a straight line. It is moving in a straight line. So this is called as what? The same particle is moving in a straight line, then is a linear motion. But whether it's a rotation or irrotational, that we cannot say. Then you have to check that whether they are rotating about their own axis, right? It is something like this. Clear hai? So this is what basically, here you can see that orientation is not changing. Orientation is not changing means it is what? Linear, right? It is a linear, but I can say that it is a irrotational. It is irrotational flow. Now suppose there may be chance that sometimes students are confused for this one. Now you can see that the fluid particle are moving in a circular path, right? Circular flow, okay, fine, but it is a rotational. You cannot say this, because you need to know whether they are going to rotate about their own mass axis or not, right? So I can say like it is something like this. Now it is changing. Clear? Now you can see that they are rotating. So now it is what? It is basically rotational. But if it is something like this, for example, now I'm going to draw, it is something like this. Now it is a irrotational flow, right? Even though it is particles are moving in circular form, but still it is irrotational flow because it have to rotate about their own mass axis. Clear hai? Done? Okay, so this you already understand. Now next one is coming like laminar flow and or turbulent flow. Laminar flow and turbulent flow. What is this laminar and turbulent flow? When the fluid is going to flow in layer by layer, means one layer is sliding over another layer. When it is layer by layer, means particles are moving in a straight line basically, right? In a particular path, they are not mixing, the layers are not going to mix together, then it is called as laminar flow. Then it is called as what? Laminar flow. Now if fluid particle is moving in such a way that they are very random and the layers are going to be merged, right, and they are going to be collapse each other, then it is what? It is called as what? Turbulent flow. Clear hai beta? Then it is called as what? Turbulent flow. Now if you want to check whether the flow is laminar or turbulent, then there is one number. There is one number called as Reynolds number, right? There is one number called as Reynolds number, and with the help, this is defined as inertia force by viscous force. We'll discuss this in very much detail, don't worry. We'll discuss when we'll discuss the pipe flow, when we'll discuss the dimensional analysis, and this dimensional numbers, then we'll discuss this part in much detail. But for time being, you can see that the Reynolds number is basically rho VL by D. Rho VL by mu. Correct? Reynolds number is rho VL by mu. Now for pipe flow, if I talk about it, for pipe flow, if Reynolds number is less than 2000, then what we'll say that? We'll say that it is a laminar flow. And if Reynolds number is greater than 4000, then we'll say it is a turbulent flow. And in between it is a transition. If the Reynolds number value is between 2000 and 4000, then it is a transition zone basically. So that is for pipe flow, right? For open flow it is different, the values will be different, but I'll tell you. Okay, so now you can see that during the flow, when the fluid particle move in a layer, right, with the one particle slide over another particle, means particles are not going to mix, they are sliding over each other, then it is called as what? Laminar flow. Okay. Okay, so these are the, for your notes, you just note it down. So here in case of turbulent flow beta, the fluid particles are going to continuously mix from one layer to another layer. It is a very disorganized form of motion. Which one? Laminar turbulent flow basically. Clear hai? Now the next one is compressible flow and incompressible. That I already told you in very first lecture, right? That if the flow is compressible, it means that there is a variation of volume, or better we can say density. There is a change of density with respect to pressure. So during a fluid flow, if the density is changing, because of the pressure, then it is called as what? A compressible flow. but in most of the liquid flow, basically what is happening in most of the liquid flow, what is happening, that the density is not changing with respect to the pressure or with respect to the flow, whether it's a space coordinates or time coordinates, then we will call it as an incompressible flow. Generally our study is basically limited to the incompressible flow. Compressible flow also we will discuss, but that is a completely different topic. That is completely different topic. Clear hai? Okay, now next one is coming like 1D, 2D and 3D flow. 1D, 2D and 3D flow. Now please try to understand, as I'm saying that the any fluid particle or any behavior of the fluid flow, if you want to learn the behavior of the fluid flow, then you must know that the any property is going to vary with some parameters. Just now I told that the properties are going to vary by space coordinates or time, right? Basically it is depend upon two things, space and time. So space coordinates are what? X, Y and Z. Space coordinates are X, Y and Z, and this is time basically. So I can say that in the analysis of fluid flow, right? Sir, what is the difference between rotational and circular flow? I told na beta, in case of circular flow in GK, in case of circular flow, the fluid particle will not rotate about their own axis. They are rotating like this. They are rotating like this, but they are not rotating about their own axis. Okay. Okay. Now please listen here. So whatever properties are there during the analysis part, they are depend upon the either space coordinates, that is X, Y, Z, and or time coordinate. Now if flow is steady, then property will not change with respect to time. That means time will be not the parameter. If it is a uniform completely, then it will change only with respect to time. It will not change with respect to the space. Now in some cases it is found that the variation of property is only in one particular direction, right? Only in one particular direction, right? Then it is called as 1D flow. That is called as 1D flow. For example, I'm going to share you here, that then you'll understand clearly. Then you'll definitely understand. Please listen here carefully. For example, this is a pipe flow, right? This is a pipe flow. Pipe flow. Here 3D diagram is very difficult to draw, so 2D only I am drawing, but you will understand, don't worry. Now please listen here. Let's say here I am talking about the fluid flow I am going to analyze. Now in this one I am assuming that steady flow first. First I am assuming steady flow. Steady means what? Now the flow will be dependent on only space coordinate, means X, Y and Z. Steady. Okay, steady ho gaya. Now second point. Now you see that this is X basically. Let's say this is X and this is, let's say, Y, and this is Z. So Z, it is difficult to represent Z. So for timing, X and Y you can see. Now here if I draw the velocity, right, let's say here velocity is velocity profile is something like this. Velocity profile is something like this, right? It is something like this. So everywhere is same magnitude, beta. Everywhere it is going to be same magnitude. Same magnitude. Please listen here carefully. Please listen here carefully. Now this is X direction, and after some time, or like, okay, is it study, so no problem. So now I'm changing the location. Now I'm changing the location, beta. Now I'm changing the location here. Now I'm changing the location. So here also the same thing. Or okay, wait, I'll draw like this. Now you can see that. Now if you move from any point, right, let's say you start from this particular point, right? Now this particular, if you move in Y direction, then is this property is changing? Let's say it is a velocity. Is the velocity is changing? No, it is not changing. Are here also same velocity, here also same velocity, here also same velocity, here also same velocity, here also same velocity. Now if you move in x direction, initially you are here, now you are moving in this direction, now you reach here, so you can see the velocity decreases. You are getting my point now. So in this diagram it is clear that whenever you are moving in x direction, then velocity profile is changing. Basically velocity profile is changing, means properties are changing in x direction, but it is not changing in y direction. 3D is difficult to show, but it is not changing, let's say, in z direction also. Now it is called as 1D flow. Now it is called as 1D flow, beta. What is called as a 1D flow? Everyone is clear, beta? Here everything is clear. Please listen here carefully. Most of the time students are not able to visualize that how it is 1D flow or how it is 2D flow, but just they remember that if it is only depend upon x, if it is only depend upon y, then it is a 1D flow. If it is depend upon two space coordinates, then it is a 2D flow. If it is depend on all the coordinates x, y, z, then it is called a 3D flow. Simply they are thinking like this, but you need to understand. Now you see in this diagram, if you are moving in y direction, then velocity is not changing, but if you are moving x direction, then velocity is changing. So basically what this is 1D flow. Okay, now coming to the next that okay, now coming to the next, let's say now profile is something like this. Now please listen here carefully. Now please listen here carefully. So if you move in y direction, suppose this is your point. Now if you are moving in y direction, if you move in y direction, then also there is a variation of velocity. If you are moving in y direction, then also there is a variation in the velocity. If you are moving in x direction, then also there is a variation in the velocity. Here you can see at the same, here this is the velocity is more, but here is velocity is less. So in x direction there is a variation of velocity, in y also variation of velocity is there. So this is 2D flow. Similar 3D I cannot show here, but 3D means it is going to that variation of the property is in all the direction, that is called as 3D flow. Clear hai? Up to here any confusion? No confusion at all. Now I am going to tell you few of the important lines. Few of the very important lines are there that I am going to discuss here. The very first line I am going to tell you about the path line. That is a path line. Now the path line is the line drawn by the single fluid particle over a period of time. Let's say one particle is there at this particular point, right? This is at one particular point. So at t is equal to 0 time, it is here. Now after 1 second it is here. Afterward this is t1 I am writing. Then after 2 seconds it will be here, t2 I am writing. Then after some time t3, t4. Clear hai? Now same particle, see suppose some flow is there, उसमें क्या करिए, just put one colored ball, right, colored particle, just put one colored particle. Now you have to visualize that how this colored particle is moving, right, and that only you have to draw. So basically this is a period of time, this is over a period of time. This is very much important. This is not instantaneous line, beta. This is not an instantaneous line, this is over a period of time. Now if I match all these points, then it is called as what? This is a path line. This is called as what? Path line. Very simple line. It is most simple line, and only the thing is you have to do is in the flow you have to drop one colored ball. Suppose some flow is there and you just thermocol ball you put, then it will start moving, right, and you just locate the the path. You just locate the path, then it is a path line. Very simple. Now as it is the line, it is not instantaneous line, so it can cut itself. See, two path line can intersect each other, first thing. Second point is that even one path line can intersect itself. One path line can intersect itself. Now please listen here carefully. Please listen here carefully. Now if I start from here to t is equal to, suppose this is a particle, this is a particle. Now for b particle I am talking about. B particle t naught, it is here, after some time it is here, t1, after some time it is here, t3, t2, after some time it is here, t3, after some time it is here, t4, t5. Now if I match this is another path line. Path line for a path line for particle A. This is the path line for particle B. Now please listen here carefully, one more point, one very interesting point. Sometimes students are thinking, sir, what about this point, at this point a particle is there or b particle? Are bhaiya, both will pass but at different time. Both will pass at different time. You can see that this is basically pass at which time? After third second. Here it is pass after first second itself. You are getting my point or not? So basically both are going to pass from the same point and at different time. Even suppose there may be chance that let's say particle C, I'm drawing as some particle is there C, right? So here I have a C particle. Now C particle at t is equal to 0, it is something like this. Then after 1 second is t1, then it is t2, then it is t3, then it is t4, then it is t5. Now if I match all these points, so what I will get? I will get something like this. I will get something like this. So you can see that the path line can cut itself also, because it is not an instantaneous line. Clear hai? So this is path line for C, particle C. So path line can intersect because the point of intersection of two particles may come in different instant. Clear hai this point? So they can this path line can cut itself or it can cut the other path line also. Clear hai? Next, coming to the streamline. Now streamline is basically kind of imaginary line. It's a kind of imaginary line. Practically we are not going to find it out. Practically this only equation we are going to find out. Now streamline is a line in the flow. It is drawn in the flow. In such a way that at the every point, the tangent at every point give the direction of velocity at that particular time. You are getting no problem. See, suppose this is what, this is basically one line. This is, let's say, streamline. First thing is that first please listen here carefully. It is an instantaneous line. It is kind of snapshot. You are taking the snapshot basically. You are taking the snapshot of the flow. That is basically what is streamline. Now please listen here. Don't think that these particles are the same particle. No, this is another particle. This is another particle, right? And this is another particle. This is another particle. Okay, please listen here carefully. So all these particles are different. Path line is for one particular particle. One particle, how it is flowing. That is what path line. But this line is basically for different particles. They are joining the different particles in such a way that the tangent drawn at that in that line anywhere if you are drawing a tangent, then it will give the direction of flow at that particular point. Suppose you hear some some particles are there. Let's say here we have another particle. Now at this point, if I draw the tangent in this line, in this curve, then it is give the velocity or direction of velocity at that particular point. clear hai? Now the very important point that if it is a steady flow, then it will be a fixed, right? It will be fixed, it will not change, suppose one flow is there, right? One flow is there. If you are taking a snapshot, at 10 o'clock, then also it will be look like same. After half an hour you are taking, then also it is coming same snapshot. After half an hour it's coming same snapshot. Why? Because if it is a steady flow, means with respect to time, the velocity will not change. Sir, here velocity direction is changing. Velocity direction changing at different location, but as per time is concerned, this is not going to same. Like at t is equal to 0, the velocity direction at this point is same. At t is equal to 2 also it is same. T is equal to 3 also it is same, right? So at location, if you say the velocity direction is not changing if it is a steady. So what I'm trying to say that for steady flow, this streamline will not change. It is going to be same streamline will be there for steady flow, right? In unsteady flow, the velocity direction will change with respect to time. So at different time, if you take the snapshot, then pattern will be changing. So what I'm trying to say, the streamline is fixed for steady flow. If flow is steady, then only it will be fixed value or fixed line. Basically it is a fixed line, the shape will not change, the line will not change. But if it is an unsteady flow, then at every second the pattern is going to change and this streamline is going to be changing. Clear hai this one? Now next point I'm saying that streamline cannot cut itself, or two streamline now cannot cut each other. Please listen here carefully. So what these are the properties. First I'm going to talk about properties of streamline. Please listen here carefully. ध्यान से समझिएगा everyone. Yes, tell me if you have any doubt. East, west, side west. Please listen here carefully. Thank you, Vaishnavi. Okay, first focus on the studies. Okay, now please listen here carefully that whenever I'm talking about the streamline, then streamline instantaneous line. So two streamline cannot cut each other. Why? See, this is 100% correct. Like for example, this is one extreme line, right? It is a one extreme line, and it is another extreme line. Now it is wrong. Why it is wrong? Because it is a same time, na? It is a snapshot. It is instantaneous lines. So this is at one. Now at this point, which particle is there? The direction is, there are two directions, na? Basically this is one direction and this is another direction. You are getting my point or not? So how it is possible that at one point two directions are there in the same time? No, it's not possible. So I am saying that it is an instantaneous line, beta. It is a instantaneous line. As it is an instantaneous line, so two extreme line cannot cut each other. Never ever. Whether it's a steady flow or unsteady flow, doesn't matter, but they cannot cut each other, and even they cannot cut itself also. Because if it is one particular streamline, then how it is possible that here at this point two directions are there? That is not feasible. So the most important point, again I am going to explain, this streamline is the most important one. What is streamline? First thing is the imaginary line. Second thing, you need to understand that it is a kind of snapshot. Third point, you have to study that it is going to give the, it is matching the different particles. It is matching the different particle at the same time. It is matching in such a way that if you draw the tangent at that at any point in the line, then it will give the direction of the flow. Okay. Now the next point, we get to know that it is an instantaneous line. So two extreme line cannot cut each other, and one line cannot cut itself also. Clear? This point is clear. So two extreme line at given instant cannot intersect each other. At a point of which two different velocities will be there, and that is not possible. Okay, this point is clear. Okay, now listen here that okay, equation I'll tell you. First, shall I tell the equation or like? Okay, let me give you the equation first. Let me give you the equation first. Please listen here carefully. Please listen here carefully. One thing you need to understand, that whenever I'm going to write the extreme line. Now, if you want to represent the velocity, right? Velocity, suppose one random motion is there, right? Suppose this is one particle. Just assume that it's a particle and it's moving like this. So it is basically covering the distance in x direction also, y also, and z also. So for dt time, suppose it is covering dx distance. So what is velocity in x direction? Please listen here carefully. This is very important. What I'm trying to say, beta, in general motion, right? In general motion, suppose this is one particle, right? In general, now it is moving like this. So it is t is equal to 0, t is equal to 0. Now it is moving like this. Now t is equal to some 1, t is equal to 1, d or dt, t is equal to dt, t is equal to 0, t is equal to dt. So in dt time, it is covering some distance in x direction also, some distance in y direction also, some distance in z direction also. So basically, whatever velocity is there, that have three components, because velocity is what? Velocity is a distance per unit time. Time is same only. Distance are changing with respect to time, means it have many components. So I am going to classify in a three perpendicular axes. Like for example, I am writing, see, v is basically the in general velocity, but I am writing here u is what? Basically u is the velocity component in the x direction, means it is covering dx distance and dt time. So this is basically u, dx by dt. Same particle is there, same, like it is moving in general motion, but it is covering dx distance. Similarly, in y direction it is covering dy by dt, so that is represented by v, and w I am writing, that is dz by dt. Now if I represent the complete all three with this general motion, if I write in vector form, then v can be written as like v is nothing but what? Ui plus vj plus wk. This you already know, right? This much vector you know. So this is a velocity. Basically velocity is represented like this, right? Clear hai beta? Clear hai? Now please listen here carefully. Suppose any general motion is there, right? Okay, so I can say that v is equal to ui plus vj and wk. Now what is uv and w? Uv and w is the component of the velocity in x and y and z direction. Now if you want to find out magnitude of v, then it will come, you already know, that is under root of u square plus v square plus w square. Even theta also, value also you can find out. Clear hai? Now if I talk about the 2D flow, I am going to talk about 2D flow. So for 2D flow, it will not cover any distance in z direction. So basically w value is going to be 0. So basically 2D flow, v value will come u I plus v j. Now suppose it is in general, which is the particle is initially, see, 2D means a plane, in a plane, basically it is in a plane. So this is the initial condition 1, and after dt time it is reaches somewhere here 2. It is something after dt time, in dt time. So it is covering what? Two distances basically. It is covering dx distance this side, dx distance, and this is covering dy distance. Now what is the value? What is the, I can say that u is equal to what? Dx by dt, and v is equal to, or dt value can be written as dt is equal to dx by u. Similarly, dy can be written as v is equal to dy by v. So dy by dt. So dt value will come dy by v. Done hai. So now here you can say this is equation number 1, let's say this is equation number 2. Now dt left hand side is same, means right hand side will also be same. Right hand side will also be same, so I can say that dx by u is equal to dy by v. Now this is the equation of streamline. It is not practical. Practically we are not going to find out. You don't think, most of the students are thinking that sir all these lines are practical lines na, like a path line, streamline, streak line, all these. No, path line is a practically you can draw, right, but streamline you cannot draw. You are getting my point, because it's an instantaneous one, right? Okay, now dx by u is equal to dy by v. Okay, now please listen, this is the equation of streamline. Equation of streamline. Done hai? Clear hai? Okay. Next important point is that, next important property is that flow cannot cross this line. Flow will be always along the streamline. Flow will be always along the streamline. Flow cannot cross this, because it is representing the velocity na bhaiya. Are dekho, suppose this is a streamline, right? So at every point if you see, then flow direction is this one na. This is the direction of flow. So how the flow is going to be crossed? It is representing the direction of the flow. So obviously if the flow direction will be something else, or it is crossing, then how it will be a streamline? इसका पर्पस ही यही है कि भैया ये डायरेक्शन बता रही है, एट एनी पॉइंट डायरेक्शन है. अगर क्रॉस कर जाता है तो फ्लो, तो इसका मतलब क्या है? फ्लो अगर इसको क्रॉस कर जाता है मतलब क्या है? फ्लो की कुछ और डायरेक्शन है, then streamline is not correct. You are getting my point or not? So flow cannot cross this streamline. In other words, discharge between two extreme line is also always constant. See, basically this is, let's say, one extreme line, right? This is, let's say, one extreme line, and this is another extreme line, right? Another extreme. Now in this one, the discharge is going to be, whatever discharge will enter here Q, same discharge will come out here Q. Why? Because it cannot cross the line, right? It cannot, see, ये तो भाई cross ही नहीं कर सकता ना. Suppose this is one line, right? This is another line. अब जगह नहीं है इसमें, बीच में आपको जाना है, तो क्या करोगे? जो जितने लोग यहाँ घुसेंगे उतने लोग बाहर निकलेंगे. It's kind of, cave. One cave है, right? वो क्या होता है ना, क्या बोलते हैं? Bridge, let's say. It's a bridge. Now bridge is over that, you cannot cross the bridge na. So the people who will enter, same people will come out from another side. You are getting my point now. So discharge is going to be constant. Discharge is going to be constant. Clear hai beta? Okay, area may change, velocity may change, properties may change. That is a different thing. Properties may change, but discharge is not going to same. Whatever number of particle will enter, same number of particle will come out also. Clear hai? This is basically the properties of extreme line. Okay. Now similarly, one tube is there, right? If I match the different extreme line, let's say for example, now here these are the different extreme line. For example, this is the one extreme line, this is another extreme line, this is another extreme line. Okay. सर वो जो 7 days फ्री वाला समय, उसमें फ्लूइड पूरा कवर है, कोई हिडन टॉपिक है, ओनली पेड स्टूडेंट्स के लिए? नहीं, उसमें तुमको मिल जाएगा. यू विल गेट कंप्लीट. मेरा भी पार्ट, मेरा जो फ्लूइड मैकेनिक्स चल रहा है वो तो नहीं कवर हुआ, लेकिन बहुत सारे और फैकल्टीज़ ने पढ़ाया हुआ है, उस पर मिल जाएगा बेटा. मेरा तो अभी पूरा कंप्लीट नहीं हुआ है, तो जितना कंप्लीट हुआ है उतना मिल जाएगा. नहीं, उसमें कुछ भी हिडन नहीं है. पूरा जो प्लस वाले स्टूडेंट्स को मिलता है, पेड बच्चों को मिलता है, सेम ही मिलेगा, डोंट वरी. तो ये एक्सट्रीम ट्यूब हो गई. ना एक्सट्रीम ट्यूब इज बिहेव लाइक अ फिजिकल ट्यूब ओनली. अरे देखो, ये मान लो एक ट्यूब है, राइट? ये मान लो, इसमें देखो, ये मान लो एक ट्यूब है, राइट? ये मान लो एक ट्यूब है ना. ये ट्यूब में क्या होगा बेटा? अब ये ट्यूब में ये ऊपर लाइंस बनी हुई है, राइट? ये लाइंस बनी हुई है, ठीक है. Now it is a practice. अब अगर इसके surface मत assume करो, don't assume that is a surface, just assume that is a lines basically. But whatever flow is going to take place, that cannot cross these lines, that cannot cross, so no fluid is going to come out, no fluid is going to, it is just like a physical tube only, it is just like a physical tube, so it is helpful in our practical applications. So we'll solve one problem on this and then we'll stop for today. We'll solve one problem on this and then we'll stop. Just read this problem better, just read this problem. A flow is represented by V is equal to AXI, so V vector V is equal to AXI vector plus AYJ. It means that it is a 2D flow. It is basically what? 2D flow. Why? Because only U is there, V is there. So U value is what? Basically U value is A into X and V value is A into Y. Where A is a constant, then find the equation of streamline. Very simple, right? Equation of streamline. So what is equation of streamline? Dx by U is equal to dy by V. Dx by U is equal to dy by V. Just put the value, you will get the answer. Just put it. Everyone put these values and tell me. Sir, I am following you from ACE to Prep Ladder to Unacademy. Just for your teaching. Thank you. Thank you, Mr. Birds. So just put the value here, so I can write here dx by A into X is equal to dy by A into Y. So A is going to be cancelled out. So this is going to be like ln x. If you integrate this one, just integrate this one. So it will come ln x is equal to ln y plus some constant. So ln c I am writing ln c. So this can be written as ln x is equal to ln y into c. ln y into c. Clear hai? ln y into c. ln y into c. So just take antilog. So x is equal to y into c. Now they are asking that this is equation A, right? But they are asking that at this particular point. So at this particular point you can find out the value of c. So at 1 comma 2, it is passing through 1 comma 2. Now this line is going to pass from 1 comma 2. 1 means x value is 1 and 2 value is y. So 1 is equal to 2 into c. So c value will come 1 by 2. So just put this value here. So you will get from equation number x is equal to y into 1 by 2. So 2x minus y is equal to 0. This is the answer. Clear hai? Any confusion? Right. So this is basically about streamline. The streamline. So streamline we studied, path line we studied. Few more lines are there, like timeline is there, streak line is there. So that we'll discuss in next lecture. Okay. Streak line we'll discuss. Okay. Now please listen here carefully. Few more information. One student was asking about this one. See here, if you are going to use this code, that is SHIVAM101, if you take this code, then for 7 days you will get the plus subscription. Means whatever the paid students are getting, same thing you are going to get to experiences. Basically you just experience that. If you like it, then you can purchase. Otherwise the benefit is that even if some topics are left, that those topics you can cover in 6-7 days itself. Clear hai? Then the next point is that basically the people who are preparing for GATE 2023, the people who are preparing for GATE 2023, so for those students, basically 2 batches are launched. One is Brahmastra Plus batch, another Brahmastra YouTube batch. So like faculties are basically same, but the practice and test series and material, everything you will get in plus batch only. So if you are joining this plus batch, then you will get a discount, SHIVA, maximum discount you will get by using this particular code, okay, Shivam 101. Acha, the people who are preparing for GATE 2024, for them one Gurukul batch is there, right? In this Gurukul batch also, if you want maximum discount, then it is just started, like 14th of October only it is started. So first subject is going on, that is by Rajiv Kumar sir. Metal cutting is going on, and okay, one more thing, that you have always option of either taking plus subscription or iconic subscription. If you are taking plus subscription, then obviously you'll get lectures of all the educators, digital notes, live classes, test series, everything you will get. But if you are going for iconic, then you will get something extra also, like customized doubt clearing sessions, right? And printed notes you will get, live mentorship you will get, right? So these are the extra benefits. Then okay, the people who are preparing for GATE 2023 or ESE 2023, for them 4 months subscription is launched. This 4 months subscription is launched, that is 19,240 for mechanical. And if here if you use my code SHIVAM101, then you will get some 20% discount also. Okay, so okay, less than 6 months are remaining, beta. So I'll suggest you that if you want proper guidance, then you can go for iconic subscription. So these are the price details basically. So in 12 months, right, if you are taking 12 months subscription, then it will cost you plus subscription will cost you only 3,599, and iconic will cost you 4,417. And one more thing, that in this also you'll get discount. This is not the this actually you have to pay less than that. SHIAM101, only this code you have to use. Okay, so this is all about today's class. So we'll meet in next class very soon. Thank you.